Hello everyone, welcome to the Bodhi Academy. In today's video, we will continue the class 7 math chapter, that is integers. So, in the last two videos, we have seen or recalled what are integers. We have performed some basic exercises of these integers, and then we learnt about the properties of addition and subtraction of integers. So, in these properties, we learnt about the first property that we saw was closure under addition. So what this property said, or according to this property, for any integers a and b, the sum of the two integers, the answer is always an integer. So for any integer a and b, the sum of these two integers will be always an integer. Then second property was closure under subtraction. So in this, for any two integers a and b, the difference of these integers will also be an integers. The answer of a minus b will always be an integer. Then the third was commutative property, in which for any integer a and b, a plus b was equal to b plus a. So for addition, if we change the places of the integers, still the answer was the same. So a plus b is equal to b plus a. But in case of subtraction, a minus b was not equal to b minus a. So commutative property was not true for subtraction. Then associative property. In associative property, we have seen that a plus b bracket plus c is equal to a plus b plus c. So if we have any three integers a, b and c, so the sum of a plus b plus c is always equal to a plus the sum of b plus c. Then the last property that we saw was additive identity, that is 0. So in this, any integer a plus 0 always gives us the integer itself. Okay, so this is, thus 0 is called a additive identity of the integers. Now in today's class, we will see the properties of multiplication of integers. So the first property in these properties of multiplication of integers is the closure under multiplication. So in this, for any integer a and b, the product of these integers, that is a multiplied by b, should be an integer. For this property to be true, the product of any two integers a into b should also be an integer. Let us try to solve some problems or some examples to verify this property. So for example, minus 20 into minus 5. Here we have a first integer, that is, suppose a is minus 20 and b is minus 5. So the product of these will be 100. So is 100 an integer? Yes, it is an integer. Then b, we have minus 30 into 12. So we have a and b. Now the product of these will be 360. So is minus 360 an integer? Yes, it is an integer. So for this problem also, this property is true. Then let us try for another one. For example, minus 4 multiplied by 0. Now here what will happen? We will get the answer as 0. Is 0 an integer? Yes, it is an integer. Then another example we can take is minus 8 into 9. So here what answer will get? Minus 72, which is also an integer. Another example, we have 0 multiplied by 15. We will get the answer as 0, which is also an integer. Then 35 into minus 1. So here we will get answer as minus 35, which is an integer. So here we can see that the closure under multiplication property is verified, since for any two integers a and b, for any two integers a and b, the product of this integer, that is a multiplied by b or a into b, is always an integer. So we can say that integers are closed under multiplication. Thus we say that integers are closed under multiplication. Then let us see the next property. So the next property is the commutativity of multiplication. We had seen this in case of addition. So let us see commutativity of multiplication. Now here what will happen? For any two integers, a and b, we have to see if a multiplied by b is equal to b multiplied by a. So in case of addition, how it was? A plus b was equal to b plus a. So even if we change the position of the integers, the answer remained the same. So same way we have to check the commutativity of integers in case of multiplication. So here also we have to see that if the product of a and b, if a multiplied by b is equal to b multiplied by a. So let us see some examples for this. So the first one, we have 3 into minus 4. So these are our two integers a and b. So what will be a into b? First we have to express these integers in this form, a into b, and then we have to find the product. So we will have minus 12 as the answer. Now we have to check as b into a. So our b is minus 4 multiplied by 3. Here what we will get the answer? We will get the same answer as minus 12. So in this case the property is verified. Let us see some more examples. B, we have a as minus 30 and our b is 12. So first a into b, that is minus 30 multiplied by 12. We will get the answer as minus 3360. And then we have to do b multiplied by a. So here it will be 12 multiplied by minus 30, and for this also we will get the same answer, that is minus 360. So even for this example the property is true. Let us see another example. So we have a as minus 15 into b as minus 10. So here we have a multiplied by b, which is equal to, it will be minus into minus, it will be plus, and answer is 150. So now let us do b multiplied by a. So it is minus 10 multiplied by minus 15, and we will have the same answer, that is 150. So here also we see that a multiplied by b is equal to b multiplied by a, that is minus 15 into minus 10 is equal to minus 10 into minus 15. Then let us see some more examples. We have minus 17 into 0. So a into b, here we will get the answer as 0. Now we will do it as b into a. So 0 multiplied by minus 17, which will also be 0. So here also a into b is equal to b into a, that is minus 17 into 0 is equal to 0 into minus 17. Then last example is minus 15 into minus 1. So here we will get the answer as 15. Minus minus will become plus, 15 into 1, 15. Then b into a will be minus 1 into minus 15. Here also we will get the same answer, that is 15. So here we see that for any integer a and b, if a and b are any two integers, then a multiplied by b is equal to b multiplied by a, and thus we say that multiplication of integers is commutative. Then let us see the next property, that is multiplication by 0. So the third property is multiplication by 0. So in this what will happen is, we know that when whole numbers, that is when whole numbers are multiplied to 0, the answer is always 0, right? So these whole numbers, what will they consist of? These will consist of 0 and all the positive integers. So let us, we already know that for positive integers, if we multiply any positive integer to 0, it will be, the answer will be always 0. So let us verify for negative integers. If we multiply negative integers to 0, then what we will get is the answer. So we will solve some example. Minus 3 into 0. What will be the answer of this? Minus 3 into 0 will be 0. Then 0 multiplied by minus 4. Here also the answer will be 0. 4 multiplied by 0 is 0. Then minus 5 multiplied by 0. It will also be 0. So here we see that for negative integers too, if any negative integer is multiplied by 0, we will get the answer as 0. So we say that product of any integer with 0 is 0. Therefore for positive as well as negative both, so the product of any integer with 0 is always 0. That is, if a is any integer, then a multiplied by 0 will always be 0, or which will be also equal to 0 multiplied by a. Then the next property after multiplication with 0, multiplication by 0 is multiplicative identity. So the next property is multiplicative identity. Let us see what is multiplicative identity. So now for whole numbers, we have learned that 1 is the multiplicative identity. For all the whole numbers, that is any whole number a, if it is multiplied by 1, we will get the answer as a only, the number itself. For example, if we do 2 multiplied by 1, we will get the answer as 2. If we do 8 multiplied by 1, we will get the answer as 8 itself. So let us see for whole numbers it is true. That means for all the positive integers, 1 is the multiplicative identity. So multiplicative identity. Now let us see if it is true for the negative integers. So let us see some examples. We have minus 3. We have a as minus 3 multiplied by 1. So the answer will be minus 3. 3 into 1 is 3. Plus into minus is minus. Then another example, we have minus 4 into 1. The answer will be minus 4. See, we have minus 8 into 1. The answer will be minus 8, or the integer itself. Then we have 1 multiplied by minus 26. So we also will get the answer as minus 26. So from all these examples we see that 0 is the multiplicative identity for all integers, positive as well as negative, since for any integer a, a multiplied by 1 is equal to a, which is also equal to 1 multiplied by a. So this is our fourth property. Then the next property that we will see is associativity of multiplication. So associativity of multiplication. Let us see what this means. Now for addition, we have seen that a plus b plus c was equal to a plus b plus c, right? We have already learned this. Now let us see for multiplication if this property can be true for multiplication too. So here how it will be: if we have any three integers a, b and c are any three integers, then for this property we have to check if a multiplied by b into C is equal to A into B into C. Okay, so this is what we have to check. Now for this, first we will need 3 integers A, B and C. Then the next thing that we'll need is the expression A into B into C. So we have to put these integers that we have into these expressions and then try to solve these expressions. So the second expression that we want is the second part of this equation, that is A into B into C. And then we'll see if A into B into C is equal to A into B into C. So then this is what we have to check. Now let us take our first 3 integers. We have -2, 3 and 4. So these 3 integers are our A, B and C. So -2 is A, 3 is B and 4 is C. Now let us put these integers into these expressions. So we have A into B. We have a bracket into this C. Then we'll try to solve this first. So what this will be, we'll have -6 multiplied by 4, which will be equal to -24. Then we'll try to put these integers into this expression and it will be -2 multiplied by bracket 3 multiplied by 4. So it will be -2 multiplied by 12 will be -24. So here we are getting the same answer. So is A into B into C is equal to A into B into C? Yes. So it is equal to, this expression is equal to the other expression. So let us see some more examples. So the second example is, we have A as 1, B as -5 and C as 9. So first we will do A into B, A into B into C, and then we have A into bracket B into C. Now let us solve these two expressions. First we will get 5 into 1 is 5 and the minus sign into 9. We will get the answer as -45, and over here we have 1 multiplied by -45. So the answer will be -45 here as well. So we are getting the same answer. So bracket A into B into C is equal to A into bracket B into C. Then we will see another example. So another one we have -4, -3 and 5. So these are our A, B and C. So first we have A into B into C, and then we have A into B into C. So let us solve these two expressions. So first here we will have minus into minus plus 12 into 5, that is we will get plus 60 as an answer, and then we have minus 4 into minus 15. Then minus into minus will get cancelled, or it will be minus into minus will be plus. You also will get the answer as 60. So in this case also it is true. Then we will see the last one, fourth one. So here we have the three integers as minus 5, 0 and 12. Now let us see A into B into C and A into B into C. So we will solve this. Minus 5 into 0 will be 0 into 12, which will again be 12 into 0 will also be 0. Then over here we have minus 5 into 12 into 0 will be 0, and then again minus 5 into 0 will also be 0. So it is true in this case also. Thus we find that for any three integers A, B and C, A multiplied by B multiplied by C is equal to A multiplied by B into C. So thus we say that multiplication of integers, thus we say that multiplication of integers is associative. So this was the associative property of integers. Then the next one, next property that we will see is distributive property. So the next property is distributive property. Now let us see. Now here in this property, the multiplication of integers distributes over their addition. So what this means, the multiplication of integers distributes over their addition. Now in other words, if we have any integer A, B and C, then A multiplied by B plus C is equal to A multiplied by B plus A multiplied by C. So this is what this property states. So if we have any three integers, that is A, B and C, then A multiplied by B plus C. So here A is multiplied to the sum of these two numbers, and it states that if we multiply A into B and plus A into C, then both these will be equal. So let us see some example. We will create the same table like this, because we have two expressions that we have to solve and see if we get the same answer. So first we have our three integers a, b and c. Then we have our first expression 1, that is a multiplied by b plus c. So this is our first expression, and then our expression 2 is a multiplied by b plus a multiplied by c. And then at the last we have to see if a into b plus c is equal to a into b plus a into c. So let us solve some examples and verify this property. So the first one is the first integers that we have are 2, 3 and 5. Are these numbers visible? So the first numbers we have are 2, 3 and 5. Now let us put these numbers into these expressions. We have a, 2 as a, then 3 plus 5. So this is our a into b plus c, a, b and c. So this is our a into b plus c. Then we have a into b, then we have a into b, that is 2 into 3 plus a into c, that is 2 into 5. So let us solve these two expressions. We will have 2 into 8 equal to, we will get the answer as 16, and then we have 3 2s are 6 plus 5 2s are 10, that is 16. So here we are getting both the answers as 16. Thus here a into b plus c is equal to a into b plus a into c. So let us solve some more examples. So a second example, the integers for second example are 0, 4 and minus 9. So first we will put them in the two expressions, that is a, first I will write the expression, that is a into b plus c, and here it is a into b plus a into c. So we have 0 as a, then 4 plus minus 9, and then here we have 0 into 4 plus 0 into minus 9. So let us solve these two. We have 0 into plus 4 minus 9 will be minus 5, and then minus 5 into 0 will be 0. Then here we have 0 into 4, which is 0, plus 0 into minus 9, which is also 0. So here also we will get the answer as 0. So yes, it is equal to this is equal to this. Then third example we have we have 1 as a, minus 5 as b and 9 as c. So Here first we'll write A into B plus C. Let us solve this. A into, here what we'll get, minus 5 plus 4 plus 9. So we'll get the answer as plus 4, and the answer 4 into 1 will be 4. Then we have A into B plus A into C. So here we will get the answer as 1 into minus 5, it will be minus 5, plus 1 into 9, it will be 9. So minus 5 plus 9, again the answer will be 4. So for these expressions also it is true. Both the sides are equal. Then another example that we have is 1, 2, 3 and minus 4. So A into B plus C and A into and A into B plus A into C. So let us solve these examples. 2 into plus 3 minus 4. So we will get it as minus 1. And then 2 into minus 1 is equal to 2. Then we will solve this one. 3 2s are 6 plus 2 into minus 4, which is, it is minus 8. And then we will get plus 6 minus 8 will be minus 2. So here in this also we are getting the same answer. Thus we see that we conclude that A into B plus C for any 3 integers, A into B plus C is equal to A into B plus A into C plus A into C. Thus this verifies the distributive property of multiplication. Now we have seen over here, we have seen these for addition, right? So will this property be true for subtraction? Let us try it for subtraction. So this is our expression. Let us now try it for subtraction. So here it will be A into B minus C is equal to A into B minus A into C. Now let us see if these are equal. Let us check if it is equal or if it is true for subtraction also. So the first example that we have is 10 multiplied by 6, the first example that we have is the integers are 2, 3 and 5. Now first we'll put these integers into the expression. So the first expression is A into B minus C, and then we have A into B minus A into C. So let us check here A into 3 minus 5, and here it will be 2 into 3 minus 2 into, sorry, it is plus 5 over here, 2 into 5. Then we have 2 multiplied by 3 minus 5. We will get the answer as minus 2. So minus 2 into 2 is minus 4. Then this second expression we have as 3 2s are 6 minus 5 2s are 10. So plus 6 minus 10, the answer will be minus 4. So we are getting same answer for both the equations. So thus we can say that A into B minus C is equal to A into B minus A into C. But still, let us solve some more examples and verify this property. So second example, our integers are 1, 5 and minus 9. So first we have A into B minus C, and then we have A into B minus A into C. So let us solve this. We have 1 here multiplied by 5 minus into minus it will be plus. So we have 5 plus 9, then we have 1 multiplied by 14. So the answer will be 14 over here, and in this case we have 1 multiplied by 5, which is 5, minus we have 9 multiplied by 1. So here it will be 9 ones are 9. So minus minus will be plus. So we will have 5 plus 9, which is again 14. So yes, it is true. Then we will see another example. So we have the integers. We have the integers 0, minus 4 and 9. So let us first put it as A into B minus C and A in and A into B minus A into C. So let us solve this. We have 0 over here. So minus 4 minus 9 will get as plus 13 will get, and then 13 into 0 is 0. Over here we have 0 into minus 4, that is 0, minus 0 into 9, that is again 0. So we have answer as 0. So yes, it is true. So for each of these case, we find that the expression for any 3 integers A, B and C, we find that the expression A into B minus C is equal to A into B minus A into C. Thus this property of distributive property is verified. Now try to solve this. Try to solve this example on your own. So is 10 multiplied by 6 minus 2 equal to 10 multiplied by 6 minus 10 multiplied by minus 2. Now, is this true? Here also it is in the same format, that is a into b minus c is equal to a into b minus a into c. So it is the same thing that we have solved. This is all for this class. In today's class we have learnt about the properties of multiplication of integers. We have seen closure under multiplication, that is if for any two integers a and b, the product of these two integers is always an integer. Then we have seen commutativity of multiplication, that is for any two integers a and b, a into b is always equal to b into a. Then we have seen multiplication by 0, that is for any integer a, when it is multiplied by 0 we get the answer as 0. Then we have seen the multiplicative identity of integers, that is 1, that is for any integer a, when it is multiplied by 1 we get the integer itself. Then associative property of multiplication is that for any three integers a, b and c, the product of a and b multiplied to c is equal to a multiplied by the product of b and c. Then we have seen last one, we have seen the distributive property, in which for any three integers a, b and c, a into b plus c is equal to a into b plus a into c. Then we have also verified this in case of subtraction. So same way for any three integers a, b and c, a into b minus c is equal to a into b minus a into c. So this is all for this class. Thank you for watching my video. Please like, share and subscribe to the Pudi Academy.